Hi, I'm Guru Rajan from Algoo Solutions. This video is about the details of state design pattern, and through this video you will learn about the structure of the state design pattern and how this was implemented previously in procedural programming and how it is different in object-oriented programming. As a precursor to this video, we have done 5 videos in the detailed introduction to design patterns. So if you have a look at those videos and come over here, it would add to your understanding. Let's start the state design pattern. Now GOF starts by saying that it allows an object to alter its behavior based on the internal state. Now I repeat, it allows an object to alter its behavior when the state changes or when the internal state changes. Let's say, now in general this is also called as objects for states or a finite state machine. Okay, if you look at the finite state machine, how you used to implement in procedural programming, let's see what this FSM or state pattern is. Let's say we have an object and it has different behaviors. It has different behaviors, right? There are different states of the object. State 1, state 2. Now there is a state, okay, and you get an event from the external world. Event 1, event 2. Now based on this and based on the current state of this object, either one of these behaviors will be executed. Now you get event 1, if it is in state 1, you will have a particular behavior. If event 1 is coming, if it is in state 2, you will have another behavior. So it's kind of an object's behavior is a function of the state. So that's what a state design pattern is. Basically an object's behavior is a function of the state. If you see in little bit more detail, if your legacy code is characterized by a lot of switch case statements with a flow of control based on the switch case, it calls for a state or a strategy pattern. Now the idea is there is an object whose behavior changes based on the internal state. This is the fundamental idea behind the state design pattern. Now let's briefly understand how you would actually go about implementing in procedural programming. Probably you will have, so just think for a few seconds how you would actually go about in procedural programming. Hope you have some ideas on that. Okay, I guess many of you got it. It's actually through the doubly nested switch case. Doubly nested switch case. So first you switch on the state and then you have a case for, this is variable 1, and then you have the state here. Based on the state you switch, and inside the state you will have another switch, and this is on event. So the outer switch will switch on the state and the inner switch will switch on the events, and then you will have a hash defined for the number of states and events. And of course you will do the state transition inside. So you have a state, you have an event, and when the event comes there is a state transition which goes to a new state, and then there is a behavior that is executed. So when the behavior is executed, it goes to a new state. Now this is the use of doubly nested switch case statements for implementing this finite state machine, or what you call the state pattern. Now the trouble is this code extensible? Can you extend this code? Can you add new states here? Right, if you want to add a new state, you may have to modify the switch statement. And you will also need to modify the behaviors somewhere else in the code. Okay, you have cleverly written the switch case in such a way that the behaviors are in a separate .c file and the switch case is in one .c file, and then the declarations, which is the state transition table, is in a separate .h file. Now you could minimize the changes but by separating the modules that change. So what does open close principle say? Draw a line between the things that don't change and the things that change. So this is the commonality versus variability principle. You clearly segregate what changes and what doesn't change in your design, and you kind of build a wall and keep one side what does not change and keep the other side what changes. So you could try to do that here by putting the behaviors in a separate file and then the switch in one file. But still you have to modify some code what you had previously written if you have to extend this code. Okay, this is implementation of a state pattern in C language or any procedural programming, right, with a doubly nested switch case statement, right. What else you could have done? In order to implement this pattern, before the advent of the design pattern or the idea of a state design pattern in object-oriented languages, what you could have done? One is this. Take a few seconds to think it over. What you could have done in order to implement this. Some of you would already be thinking about this, which is actually two-dimensional array of function pointers. Okay, which is right. So you have a function pointer. Okay, this is based on the state. This is based on the event, right? And the function is going to return void, and the function is going to accept based on what you are going to pass in. So how many of the, so each of this function pointer you have to initialize. You should initialize it to what? You should initialize it to a function or action function. So if you have 4 states and 3 events, you would eventually have 12 action functions. And then in your main code, based on the current state, you will go into this two-dimensional array of function pointers and call the functions. Is that not you will do in this case? Right. Now what do you think about extensibility of this? Is it not slightly better than the switch case? Now in the sense that this can be separately put in a .h file and the behaviors can be separately put in another file. There is a little bit of extensibility built in this. See, in fact, if you little bit go deeper, what is polymorphism? In fact, it is actually in object-oriented languages, it is actually implemented through a vtable, which is an array of function pointers. Actually, you achieve polymorphism through an array of function pointers, which you are trying to emulate in C language. And then you have all this, and you will have to implement the behaviors, of course. You have to implement all these functions, but only thing you are doing is you are giving the starting address of all these functions to a two-dimensional array of function pointers. There is little more extensibility built into this compared to switch case, right? And I'm sure many of you who have written code a little bit lower down the layers will easily identify themselves with this. Right. There is a little bit of OCP that we can bring into this. Now what the over design pattern talks about is, now let's have, now we are coming to object oriented programming and then this state design pattern. Now what here we talk about is, now we have a state base class. Okay, and I guess to get a good view of this, we would actually name all these states. We would take a real software example and see all this, but I'm just giving an outline of this design pattern to start with, because then it will be in place compared to the procedural programming one. We have a state which is the base class. We have, now this could be an interface or it could be a non-abstract class also. You could have some implementations here, right? Now you have many derived classes from this, right? Now you have what is called as a context class. Now this context class can only talk with the interface. It cannot talk with the derived classes. This is an interface. Now what is your client code doing? Let's put the client code over here, maybe here, since you can see it better. Now the client calls the context calls the base class state, and the derived classes are representative of each state. This is state 1, state 2, state 3. Now please remember, we are discussing one design pattern of the total 23 design patterns that are available here. This is a detailed introduction to the design pattern, and we are taking only the state pattern. Right, now this is the different states. Now let's say the behaviors are, let's just give a name 1, 2 and 3. Okay, and the states can be just, let's give a different name so that you don't get mixed up with the actions. Let's say S1, S2 and S3. These are the states, right? Now based on this S1, S2, S3, one of this behavior will be called. But wait a minute, what is the current state of this system? We should know that, right? Now the current state can be S1 or S2 or S3. Now the event that is coming from the main program can be E1, E2 or E3. Let's say E1 comes and it's in S1 state. Now all these three behaviors will be implemented separately in all the derived classes. There is 1 here and there is 2 here. Now the name of the function is the same, but since they are derived classes, all these behaviors will be implemented in separately each of the derived classes. Now please understand the structure very well. There is a base class state, there is a context class, there are as many derived classes as the number of states in the system. Now the client is going to call the context is going to call any of these derived class behaviors based on the current state. Now what is this context going to do? It has actually pretty important task. The context creates these base classes. First it has a pointer to all of them and it also allocates memory for them, right? The context is also responsible for state transition. Now who is going to change from S1 to S2? Okay, I get an event, I am in one state and then I go to another state while executing this behavior. Now who is going to do the state transition? Context has to do that. Now who has the record of what is the current state of the system? Who has that record? Of course context should have that. Now based on this record and the event that comes in, the corresponding action will be called through the interface. But somebody has to call that. Who is going to call that? The context through the interface will have to call one of these behaviors. So let's look at it again. The context has basically 4 responsibilities. 1, it creates objects of the derived class. It takes the request from the client and it calls the appropriate behavior through the interface. It also has the current state, record of the current state, and it also has what is the state transition that's going to be done after executing this behavior. So context is responsible for all the four. Now, how is extensibility built into this? Very easy. If you want to add a new state, you just have to add one more derived class. But please understand, you don't have to change any of the existing code except you may have to change one value in the state transition table. You may have to change the enum state, one variable, and then you may have to change the state transition table. The rest of the code, even the client code, remains untouched. You just have to code the extra derived class that you are going to add here. If you had some more space, we could as well show you the whole code. We would do that eventually in some of our subsequent videos. Hope you understood the structure of the state design pattern. And if you have a look at this once again, you would understand how it differs from a conventional implementation in C. Now in our next video, next part of this state design pattern video, we would take an actual example and see how state patterns applies for that. Let's see you in the part 2 of this state design pattern video. Have a good one.